Hi, I recently released the latest update from the Qubit CalculiX component. You can download the binaries on GitHub. We finally got the Windows history bug fixed. Also, I added the surface structure load. We can also define equations now, define a sector point card, use the initial condition for stresses. And I also added a live monitor. Just going to show that a little bit around. The surface structure load is now available on the loads. You just have to define a site set where it works on. I made a new example. It's in the directory that you can download. Under examples, you can find the bolted connector with initial stress. That's this Schondel file here. It's very similar to the other bolted connector. The only difference is that I use here the initial stress condition to pre-stress, preload the bolt. When I also in this journal I use the history output sector print. So we should get the sector print here when we are looking at the results. In the jobs monitor now, the first step is the live monitor. We also got this .sector card here. So when I now hit run, it basically reads the data from the SDA and the CVG file and make plots out of it. Just let it a little bit run. In the first step was the initial stress condition, and after that we are moving the plates. So I can now kill the job, I can load the results in, can convert them for later view in pair view. Now, just as for the FRD and that data, I can do the same for the sector print card. I can now look into the results. I can, just like for the others, get a plot or export that to a CSV file. Just to show you around what happens in the first step with the initial stress condition for preloading the bolt. That's the preloaded bolt we got here. Just with the initial stress condition. The other good thing, we also added the possibility to create equations. Now we can either define them per node or from a group of nodes and bind the different degrees of freedom. I've got an example for that too. It's the layers example here. Basically, when you do a check for coincident nodes on the volumes, you can create a group that contains those overlapping nodes, and those nodes are used or can be used to create the ratios between them. That's what I did here in this journal file. So why does it matter? when I run this short example now, and we take a look at the results, you will see that there is now yeah, that the different materials are not connected when the element matrices are built. When the stiffness matrix is built, the different materials don't bleed into the other adjacent material anymore. That could be very useful if you're doing something with composite materials. Okay, thank you for watching, and I will keep you updated.